So we were just talking about functions, prototypes, headers, and so I'm going to kind of step through this in a very simple way. And we will just start by restructuring hello world. So the most simple function is just like a function, a void function, right? It doesn't return a value. You can give it void parameters, meaning it doesn't take any value in, and I mean it doesn't have to necessarily do something, and it's just doing empty instructions on your CPU, unless if it doesn't already get optimized out. So we'll here create a function to put the hello world printing inside of. So just a simple one, my print function, and we'll give it void parameters, and then we'll just take this line here and put it in here. We don't need this, and then we can just call it, right? So we can say my print function, and because it doesn't take any parameters, because we have void here, this is void, oops, then we don't need to put anything in these brackets, but we do need a semicolon, right? And so if we make this and run it, we'll get hello world just the same. And if we debug this, we can see, if we break at 10, that now we're stopped at this line, and if we step into the function call, it goes up to my print function, and then it'll execute the code within my print function. So we can see here, GB's terrible output, hello world, right? So this is the most basic case, and we're talking about, oh, okay, we have these prototype declarations, and so before we go into like advanced function, sort of return types and whatnot, my text editor is already giving me some errors here, but if we make it, it's going to build because GCC is awesome, but it's going to tell us that we have implicit declarations, and it's going to assume then the types of the function. And this is why we also then get conflicting types, because I'm pretty sure that GCC, if it doesn't know what a function is, it says, okay, I'm going to assume that it returns an integer and takes void, I think. I'm not really sure. I have to check that out. But either way, this is the problem that is generated by not having by having the function after, from like top down where it's called in your code, and not having a function prototype. So one solution is to make my print function prototype like this. And then if we run this, we have no build errors, and we can still run it. All good, great. Or we have no build warnings, as we can see here. But this function doesn't, generally void functions that take in void parameters, I mean, they have their uses, but for basic programs, they don't really serve that much of a purpose, more than just creating sort of like nice logical blocks. Like a useful function generally takes in some parameter and will return us some value. So I'm going to do that now. And we'll make my print function, we'll make it a little more advanced. We'll start off by giving it a parameter. And we'll say, okay, we'll pass in here the string, my string that we're going to print. And in here, so ignore this if this is too complex for you, essentially we'll just say, what this is doing is that we pass it in a character array, which is a string, and then we print it, right? And so then we can say here, hello world, like that. Now if we, the function prototype no longer matches, so we need to modify it. So I think you can just leave it like that. You don't necessarily need to put in the actual name, because it doesn't care. All the compiler cares about is that it knows what data size is, what type is getting put into the function. And there we go. It runs great. Did I make this? No, I didn't. But there we go. Same thing. So this is how we pass in a parameter. So simple would be, for instance, we can pass in two parameters. We'll pass in a parameter, we'll pass in a character, and we'll pass in an integer, and we'll call this foo, and then we'll also print this. We can say print, we'll print the string, and then we'll print the decimal, or the integer. So we'll call this foo, and then obviously here we need to change our prototype to have an int in it as well. too few arguments, I didn't put in a number. There we go. And voila, we print the string, and then we're printing this other parameter. Now, we still have a void type of our function, and so we want to have functions that can also return to us things. And so we can, let's say, put in, we'll make this a val, and then we'll say int multiplier. And we'll get rid of the string. And what we'll do is we'll just, so this is still there for the completion of the demo's code, we'll make another function. And we'll make it, I'll make it before main, so we don't have to write a prototype. And we'll say we returns an int multiply, and it takes in a value, and it takes in a multiplier. And all it does is it returns to us, because we know it has to return an integer because we have an integer type of our function, it will return the value times by the multiplier. Now, multiplier. And so if we go in here, we can take some value, we'll have int a equals 2, or we just say int a. And then, for instance, we want to a equals multiply, and we want to say 3 times by 4, right? And then we can print a's value, print f, and we can see that a now has a value 3 times by 4. Now I should quickly touch on scope and what I was talking about stacks, because this will make it quite clear. If we wanted to, for instance, here, if we debug, or we say print here, print f our value, cannot type today. And now what we'll do is we'll actually val ++, right? Our value, and we'll just copy this one and return it here, right? Now we'll make another variable called val, or our val, to make it more clear, and we'll make this equal to 2. Now, I can say a equals to multiply our val, and we'll just put in 5. Now, the thing is that we've created this variable, this integer here, in the scope of my print function. And so it has a value of 2 in here, and then I'm passing it into multiply as a parameter. And so it's going to land here in val. And the thing is, we can increment val here, but as soon as this function returns, this here is a copy of our val. So the copy has been incremented, but once the function returns, the stack's destroyed and we don't have this variable anymore. And so we can see this by, if we print here our val, we make this and we run this and we go through our output a bit, we can see we've done the same stuff as before, that's fine. But what we have here is we've called multiply. So we've stepped into multiply. We have printf our value. So this val, which we passed through here as our val, as 2, gets put out as 2. Great. We then incremented the value's copy within the function's scope. So now it has a value of 3. We've now printing it, so you can see 3 here. And then we're returning this incremented value by the multiplier. So if we quickly take this again, and put it at the end, we'll put it here, we can see that in the scope of the function, it's being incremented. It's returning a value that is using this incremented copy, which makes sense, right? Because we're returning it here after this copy has been incremented and we're using it in the arithmetic. But the actual variable passed into the function doesn't change its value because the value is copied into the stack. It's sort of like copied into the function, like onto its own stack, modified there, but once the function returns, it's destroyed. So that's just quickly on scope. How we would handle this, we would deal with pointers, and we'll get to that in like later in the course. So we'll go back now quickly now we've got the basics of functions. We can return a value, takes in parameters, but now we sort of want to look more at like these header files and these function prototypes. So let's say we wanted to make my print function like in a library, in that we could have multiple C files that include or that use this function, or use a function. We'll write a new one. And how would we do this? So what we can do is, if we want to say, we can create in source, we'll create printing.c, and we'll create include printing.h. Now if I go into and modify this one, firstly we'll do an include guard. So now we've got a header file, and then if we get the C file, in here we can make some printing functions. So we'll even go another step further, and we'll also open our main file. So put him up the top. So let's actually just copy out my print function. Cool, so we'll take him and we'll move him to our C file, which is down here. So now if we try and build our code, it's going to say, hey, undefined reference. GCC can't fix this. It doesn't know where this function is. It's trying to link it, and it's saying, hey, yep, this function doesn't exist. It's that easy. So what we can do is that we can then, let's see if there's anything else I need to multiply my print function. So we have a prototype for it, but it still doesn't know where it is. It might be telling it, hey, yep, cool, this function, I'm telling it this function exists, but it doesn't find it. Probably because I need to run CMake again. But if we get rid of this prototype, yeah, we're getting this implicit declaration problem again. So it doesn't know where it is, it's taking a guess, and now we're not getting the same error from before where it's saying conflicting types, because GCC assumes the type, and it seems to work out this time, right? So how we can fix this is that we've essentially here created a C file with some functions in it. And this is what you can think of as like a library file. You know, it's got some sort of functionality, and you want to include this in your main project. In our case, this would be our main.c. So we've created our function, and now we want to create the prototype. And so the prototype we can put into the header file like this. And so now, if we know from where pre-processing of files, wherever I put include and then this file, which is called printing.h, it will copy and paste this contents into that line. And therefore it will essentially just do this again. So after pre-processing, we'll have this line back in there, right? So if we go include, because it's our source file, we'll use the little like rabbit ears printing.h. And so now if we make this, no problems at all. And we can run it, and everything's fine. And so that's the use of a header file, is that we create the C file, the C functions in the C file, create prototypes to them, so that whenever we want to use them, we can include the prototypes by simply just including the header file. We don't have to go and type out every function. Like, let's say you're using 100 functions from some complex libraries file, you don't want to type out all the prototypes you need. It's very tedious. So this is how include and headers work. So I think that should hopefully clear up the sort of confusion around function prototyping and also function return values and parameters.